Okay, so I'm just going to go through a bit of a satellite imagery presentation here, gathered mostly through four satellites, GO 16, GO 17, Himawari, and the polar orbiting satellite JPSS. Yeah, this is just a larger, um, beautiful shot of the Pacific Ocean. Not much landmass in here. As we know, Earth is a lot of water. And it's just cool to get a shot of this where you just see that element of water and subsequent clouds. So this is an extratropical cyclone in the South Pacific. The beautiful boundary layer here, cold front with cold air mass up here surging southeastward. This is a West Pacific typhoon with quite a large eye that's not that well defined, a lot of gaps in it. But what's cool here is you've got a very visible little mesovortex on the south side of the eye here. This is obviously now a much more well-defined hurricane. Can't remember exactly which one it is, but you can see it's just like perfectly closed off eye and eye wall here with a beautiful radially fanning out deck of cirrus clouds here. This is some Pacific Ocean stratus layer here that is just ridiculously well defined, like somebody came in with a fine tipped paintbrush and feathered out all of these beautiful streaks through the clouds. And then these other kind of more intense white streaks here are ship tracks from passing ships underneath that are adding moisture and heat to the atmosphere and intensifying the condensation that's happening in those tracks, allowing it to be a more dense cloud structure than the surrounding areas. This is somewhat alarming image from the north coast of Siberia, where you've got in the early spring, you've got sea ice breakup taking place here, all over here, really. And then you've got this immense amount of wildfire smoke emanating from fires just out of frame to the left here. And this interaction between kind of fire and ice is something that's happening more and more as our climate warms. And the interactions between the two are just fascinating and come with a lot of unknowns, as it were, because it's such a new kind of regime that we haven't fully even begun to understand or even study to that much of a degree. This is another interesting image from the Midwest states where we've actually got 1, 2, 3, 4 convective cells here, possibly supercells, and then what look like similar things over here, but are actually wildfires. And the similarities between the two vertically rising clouds of moisture here and smoke and ash here is rather hard to ignore. And even just given the proximity, it's obvious that there's going to be some interaction between the soot wildfire smoke here and the development of these convective cells. This is a beautiful image from the Pacific Ocean where you've got a northward moving stratus layer here being impacted by two tiny, barely visible islands here that are punching holes in the cloud layer and then creating subsequent interference waves that are interacting in between the two clouds. And then some rather dramatic boundary here that is just looks like somebody cut with a knife. This is a beautiful image of a cyclone in Australia that perfectly illuminates just the power of the ocean heating that a cyclone needs to sustain itself. So the core of the cyclone right here is actually over land and is completely void of convection. However, it retains its quite well-defined structure, leaving kind of just this ghostly cirrus structure here. And then the spiral bands here are actually this top one. It remains over water and is able to generate extremely powerful convection, and much more in a cellular-like structure, filling in the spiral band compared to the dense donut-like convection that normally surrounds the center of a hurricane or typhoon or cyclone. This now then becomes an extremely well-defined Hurricane Genevieve in the Pacific from last year, I believe, where the just exploding eye wall becomes quite visible here in the low sun angle. Beautiful image. This is Hurricane Iota from last year's record-breaking Atlantic season. Quite a large hurricane, just sprawling throughout the Caribbean. Excuse me. This, I'm sure many people recognize as Hurricane Harvey from 2018, one of the wettest and most destructive hurricanes to hit the States recently, ended up dropping over 60 inches of rain in and around the Houston area. Now we head over to the Atlantic Main Development Region, where we've got the African coast right here and multiple developing cyclones in different stages here. And what's most notable here is just the layer of Saharan dust that we can see advecting off of Africa and subsequently being pulled and ingested into this cyclone here, to a lesser degree this one, but it's quite obvious to see how it's being pulled in here. And there's, for the most part, people believe that this kind of dry air is going to put a hamper on a hurricane's development, but there's also research being done on the potential positive impacts of more Saharan air, more drier, dustier air as it relates to condensation nuclei and moisture condensation. This is now in the Antarctic Ocean, where we've got a large iceberg here, seeming to kind of like split the clouds in half here with again, this very sharp boundary that is hard to fully understand. And similarly down here with a then beautiful, complex, interacting layer of multiple waves going this way, going every way. This is a beautiful, clear image shot of Iceland, which is sometimes rare to get, where you've got algal blooms over here swirling off the coast. And down here, you've actually got, underneath this cloud layer here, you've got sea ice from Greenland, off the coast of Greenland. And now we head back to the main development region, and just this is a beautiful depiction of kind of the interaction that can sometimes take place when tropical cyclones are born out of the ITCZ, the Intertropical Convergence Zone, where the trade winds from each side of the equator meet. And so you can see this developing cyclone is still embedded within the ITCZ and won't really fully mature or develop much farther than this until it breaks free from that and becomes a full-fledged independent system on its own, separated from the energy transfers within the ITCZ. This is Hurricane Laura from last year, one of a number of hurricanes that impacted Louisiana. Bit of a smaller hurricane, nonetheless, still extraordinarily powerful. Category 4 upon landfall, and just with these beautiful fanning cirrus out on the east side of it. Now this is to the Mediterranean, where there's a lot of new interest and intrigue and research being done on this idea of warm core cyclones in the Mediterranean, where up until this point, you will only really get storms of potentially equivalent to a Category 1 hurricane in the Atlantic, which can still do a lot of damage. This is not a super well-defined cyclone. Structure-wise, it's quite impressive, but there's a lot of gaps in it, obviously. This next one then is much more compact, resembling the Atlantic hurricanes, much more obviously, and packing a big punch as it approaches Italy to the left here and Greece on the right. This is now just a depiction of up in my neck of the woods. I'm in Toronto over here, excuse me, and a beautiful line of convection developing, exploding over Michigan, heading my direction. This is a beautiful waveform void kind of cloud structure in northern Mongolia, actually, and who knows what kind of land cloud interactions underneath are causing this kind of Zorro Z backwards N, whatever you want to call it, pattern. But then the complexity and nuanced kind of division of these gravity wave structures over here and down here and all throughout here is quite remarkable. This is a beautiful image of the Kamchatka Peninsula, one of my favorite places to look at in satellite imagery, with a beautiful shot of the moon overhead. It rarely happens in these satellites because they're geostationary, rotating with the rotation of the Earth. The moon itself has to travel through the frame of the satellite, which really doesn't happen that often, but when it does, it lends itself to quite beautiful pictures. This is a beautiful depiction of an outflow boundary being created by downdrafts within a cluster of convection right here. As cool air descends very quickly through a thunderstorm updraft, or as a result of a thunderstorm updraft, once it is falling back down to the thunderstorm, if there's no more rising air to counteract it, it'll overcome that and just make contact with the ground and spread out in all directions, potentially igniting new convection as it races, in this case to the west, interacting with the different air mass over here. And as you'll see in the next picture, one of my favorite parts of nature is the parallels that exist all throughout nature, no matter what you're looking at, really, whether it's on this planet or another planet. Kind of the parallels of physics within the universe give way to the same kind of patterns all throughout the universe. And so we've got this outflow boundary here as a result of the downdraft. And then in this next image, we've got what looks like a very similar outflow boundary, except it's the interaction of the northern lights, or it is the northern lights, the interaction of solar energy being ejected from the sun and interacting with the Earth's magnetic field. You can see lights over here. This is from the polar orbiting satellite, so it's a bit more chopped up because they don't have a whole view. It's constantly rotating around the longitudinal lines of the planet. And as you can see in the next image, it literally kind of does this outflow thing where it hits, it creates a boundary moving out, and then it just kind of explodes into these beautiful patterns that anyone lucky enough to have seen the Northern Lights will kind of recognize from underneath. But the view from above is quite something on its own. These are some beautiful, what's called open cell and closed cell convection over the Pacific. Just incredible patterns here that I think I've often wanted to turn into fabric or something and make into clothing because it's that cool. This is the larger angle, wide view of that same area. You can see that closed open cell convection in here that was zoomed in from the previous picture. And here's the edge of Chile in South America. This is just a beautifully well-defined cinnamon roll kind of structure in an extratropical cyclone in the South Pacific. These are a cluster of, some of them tornadic supercells in the Midwest from a couple of years ago at sunset, with some of them, the beautiful vertical structure here casting, 100-kilometer long shadows that are much harder to notice from Earth, but from space become quite apparent. This is again a bit of a depressing image here, as we've got a beautiful cirrus fan from a tropical cyclone over Southeast Asia down here. But then to its northwest, we've just got an immense amount of smog that is permeating throughout Southeast Asia, mainly from India over here. And the thickness of it is just astounding. It's a bit more accentuated because of the low sun angle. But nonetheless, like you can even see down here, some of the higher elevation parts of India poking through the top, but down near the surface, it's just thick smog. Now, this similarly looks kind of like smog, and it's another aerosol particulate matter, but it's wildfire smoke in Canada from BC fires out here, traveling all the way via the jet stream over to the East Coast. Partly there's a cyclone up here that's helping pull that smoke over. Here's New York down here, Southern Ontario's right here. And as I see in the next image, there's quite a unique phenomena here where right in this area here, you've got a convective line of thunderstorms being born right from the middle of the thickest part of the wildfire smoke, um, which kind of lends credence to that idea of wildfire or dry air not always being a negative, something negative for convective growth. Now we travel to the southernmost tip of South America, Patagonia, and some just beautiful cloud structures and immensely complex interactions here where we've got dust being advected out of out of the landmass here out into the water. These right here, many people I'm sure have seen on land or seen pictures of, are lenticular clouds, those beautiful spaceship-like looking clouds that are stationary over mountaintops. And they look less exciting from space, but still kind of cool to see what they do look like from space. This is still now in South America, same kind of area where we've got some wildfires over here and then immense convection right here. South America outside of, or this area of South America outside of the Midwest states has some of the most intense convective storms on the planet, often creating monster size hail. This is a beautiful storm from Fiji a couple years back. And what's interesting here is we've got this kind of cut wave trough kind of thing that's embedded in the outer circulation of the storm. And it obviously you can't tell now when it's not animated, but what was happening here as this storm was spinning, this wave was not really moving at all. Everything was moving through it, and it was this kind of standing wave. What its cause or why it's there, what it's doing, is not really known. There's a beautiful sunset illuminated supercell with a massive overshooting top and above amble cirrus plume here spreading to the northwest. Just stunning on its own. This is a great depiction of a splitting supercell, Texas, Oklahoma border, where you've got the mature supercell here that then splits off into one left moving, one right moving supercell. Another just massively stunning expanse of convective, perhaps mesoscale convective system here, where you've got a large group here, and then an incredible individual overshooting top right here, and just massive amounts of fanning cirrus all around it, casting shadows from the low angle sun. So now back over to the Kamchatka Peninsula here. Well, I just like this picture because it depicts the incredible amount of just kind of swirling chaos that takes place in the atmosphere, with swirls happening all over the place. Speaking of swirls, this massive nor'easter bomb cyclone from a couple years ago is just immense, and the breadth and control that it has over the basin here is stunning. This is the East Coast here, Florida's down here. And the fact that it's literally the frontal boundary attached to this is connecting all the way down below Florida, almost to Cuba, back up to a developing low pressure system over Texas. So the atmosphere literally at times, all times really, is interacting and connected with itself in a remarkably complex way. This is Hurricane Teddy from last year, I believe, off the East Coast here, ingesting a massive amount of wildfire smoke here across Canada, with a quite well-defined boundary between mostly clear air and just smoke-filled air to the south. Now, this is Australia, and we've seen a number of sharp boundaries in this presentation, but this has to be the most well-defined sharp boundary, that just like within the cloud layer, you've got immensely fine detailed structure to this stratus layer. And then there's just the sharpest line I've ever seen in any kind of cloud layer, extending hundreds and hundreds of kilometers throughout the Australian outback. This is a rather alien-like structure of stratus clouds in the Pacific again, You can see some similarities to, the open closed cell convection. There's lots of swirling stuff going on, but even still, some of these patterns are just, these are what's called actiniform clouds, a somewhat new defined cloud that has this circular spiral structure embedded within some of this open closed cell convection. This is a view of off like a low angle view from GOES 16 of African supercells. And so they're obviously quite a distance away, but from this angle, you're quite nicely able to see the convective vertical growth of these storms. And again, in this next picture, these different walls of convection, these larger convective complexes that are just marching across the African desert jungle interface. This is a stretch of islands off the Kamchatka Peninsula with a northwestward moving layer of stratus clouds being impacted by the islands here, evaporating the cloud layer and creating open spaces here, creating gravity waves and interference patterns here, and some spiral eddies throughout here and here. This is one of my favorite images from the Amazon of sun glint essentially off of the river here, creating what looks like a lightning bolt in amongst the clouds, varying layers of benign clouds throughout here. But the next image where the sun's at a slightly different angle, you wouldn't see this at all because that's how subtle it is. This is in the Amazon again with some kind of popcorn convection where you've got no real overarching movement of air in any direction really. So you really just get these standalone single updraft, single downdraft thunderstorms that pop up, could be quite intense, but drown themselves out pretty quickly. But there's so much heat and moisture throughout there that they can pop up all over the place with this once a lifting mechanism is created. This is now down to the Antarctic with a beautiful. So this over here at top right to the top and the right is the land mass, and this is the edge of the land. All this under here is sea ice, and then here and here are the low level stratus clouds. You're not going to get much convective growth clouds over ice, although it still can happen, as we'll soon see. But you do have these just beautiful, subtle stratus clouds with some beautiful wave patterns throughout them. So this is now the North Pole sea ice here in the summer, and these are all convective storms. I don't know if some people remember, but there was a couple of years ago, 2018 or 2019, where this was quite well documented. There was lightning within these storms, and it's a pretty rare occurrence for lightning to be detected anywhere near the North Pole when you've got nothing but sea ice underneath it. But there was also a study I saw a couple within the last year that talked about increasing rates and increasing amounts of lightning at the North Pole, possibly as a result of global warming and the changing climate. This is the Arctic Ocean again, with just an incredible amount of interacting swirls here of all different sizes. Another beautiful low-level stratus spiral cloud over the Antarctic. So this is all land and ice over here, and then this spiral right here is a low-level stratus cloud. This is now over to Australia, where we had the immense fires of 2020. And I like this juxtaposition, this in the next picture. This is early in the morning, where you've got the fires still burning, but they're pretty flat. There's not a lot of convective growth within the fire yet, which is sure many people know. Fires, create so much immense heat. They're essentially capable of creating their own weather systems, creating their own thunderstorms, as you'll see in the next image with these pyrocumulonimbus clouds that, throughout the day, as there's more heat from the sun that adds to this whole system, Those flat early morning smoke plumes from earlier become just these agitated, boiling, violently, just violent firestorms that can produce their own lightning, can produce their own rain, and can produce their own tornadoes as well. This is now is in Australia still with one of the most phenomenal cloud structures I've ever seen, completely isolated in the outback, but just I can't even describe it. There's a little bit of wave structure here and just incredible structure and patterning throughout it. This, I'm sure many people remember, is one of the massive bomb cyclones from a couple years ago that traveled up the eastern seaboard, just incredibly huge, and visible here, the snow that it left behind all across the eastern seaboard, almost all the way down to Florida. This is another beautifully subtle little stratiform cloud in the Arctic um, that, like I said, not much convective clouds because of the ice air interface, but you still do get these beautiful patterns depicting some of the airflow over the ice. This now is into the Atlantic with Hurricane Dorian, essentially the best example of a near perfect or perfect hurricane that we've had in the Atlantic over the last number of years. Yeah, and this is essentially at its peak as it is over the Bahamas. Florida's right here, I believe. This is another image of Hurricane Genevieve that we saw earlier, just depicting that beautiful eye wall structure as it explodes and strengthens around the center of the storm. This is a very interesting image from the Bay of Bengal, which is harder to get imagery from. Himawari has a decent view of it at times. And this is a cyclone in the Bay of Bengal here. And then you've got the Himalayas up here. And I just love the breadth of this area here. And this is a stitched image, so it's a couple put together. Just the kind of contrast between the two landforms, or the two landforms is the wrong word. This isn't a landform. But the landform here and the complexity of the weather system over here, just a stunning juxtaposition. Now, this finally is a very interesting image from the Amazon where you've got the gray areas underneath the clouds here. There's the dark areas here of the jungle and the forest, and then the gray areas are, they're all perfectly cut and geometrical farmland or deforested land. And you can see actually that like a lot of cloud, the only place cloud really is forming within this shot is over the deforested land. And it just is really like, one of the biggest parts of global warming research right now is looking at clouds impact the radiation, shortwave radiation coming in from the sun, and the fact that a lot of clouds in general will reflect a lot of that incoming solar radiation, which would lead on its own to global cooling. But because there's a lot of other impacts that are working away from global cooling, but it's a very important factor in fully understanding just all the alterations that we're making to the planet and how it affects the atmosphere as a whole. And like this one is just so obvious. If we hadn't deforested here on this day with the same conditions, there would be no clouds. And yet we're creating the environment and the situation for new cloud growth. So just another one of these images that it becomes so obvious that we can dramatically alter the environment, not through cloud seeding, not through any kind of geochemical thing, but just literally through transforming the surface of the planet and changing the interaction of the radiation in the atmosphere. So yeah, lots to think about. And thanks for watching.